Sound confirmed. We're safe on Mars.
When it works, it's a special thrill. Nothing triggers tears of joy like landing a rover on Mars.
You'll take us.
The Curiosity rover in 2012, the twin rovers, Spirit and Opportunity, in 2004, and the mission that started it all, Pathfinder, carrying aboard the first Mars rover named Sojourner in 1997. The flight director that day was Jennifer Trosper.
We have imaging data.
Yes.
I'm one of the people who's been on the rover since the beginning, but some of the kids working on it now, they were toddlers when we landed Pathfinder, and so there's just this generational thing that we're doing at the laboratory as well.
The team at NASA's Jet Propulsion Lab is 4 for 4 when it comes to rover landings, but they take nothing for granted. When the fifth, named Perseverance, arrives at the Red Planet and begins its high-speed, high-stakes plunge through the atmosphere, the scientists and engineers well understand it could all end in a different kind of tears. No one in this business forgets the agony of 1999, when the Mars Polar Lander crash-landed on the surface.
And yeah, we all get pretty nervous at landing. There are a lot of things that can go wrong. This is a complicated vehicle. On the other hand, we all love that challenge. We love to solve problems. We love to say, oh, here's a risk. Let's see what we can do to buy that down.
The risk was palpable in mission control for the Pathfinder landing. After the Viking landers failed to detect any signs of life in the Martian regolith back in the 1970s, NASA had largely moved Mars to the back burner. Pathfinder was one of the first of NASA's so-called faster, better, cheaper missions. The idea? Jumpstart space exploration, but on a shoestring, with engineers encouraged to think outside the box. What followed was the bounce and roll landing, and the rest is history.
Scientifically, really, Pathfinder was the first opportunity to demonstrate the technology that we needed to get back to the surface in an efficient and reasonable fashion. We used airbags. We used a small robotic vehicle. We gave ourselves the ability to traverse away from the place that we landed. And I think scientifically that was something that we recognized was a powerful capability for future missions.
Golf cart-sized, solar-powered Spirit and Opportunity were the first rovers to really get down to business on Mars.
So the first two rovers that we sent, the real science rovers that we sent, were Spirit and Opportunity. Incredible rovers that really were our first time trying to be mobile geologists and mobile scientists on the surface of Mars.
By anyone's measure, these rovers were a stunning success. They confirmed Mars was once a wet place in the very distant past.
And so that strategy really began with a strategy of following the water, because we know on Earth, water is actually fundamental to how life formed and how life exists on Earth.
And their longevity vastly outstripped expectations. They were designed to operate on Mars for 90 days and drive just under a half a mile. Spirit was operational for 6 years and drove nearly 5 miles. Opportunity operated for 14 years and drove 28 miles.
And then, of course, Curiosity came with its analytical chemistry capability to really assess that ancient environment and determine that that environment was habitable for life.
Nuclear-powered and far too heavy to bounce and roll, the Curiosity rover landed via what's called the sky crane method. A descent vehicle lowered it to the surface on tethers. It worked, and so the engineers are using it again to land Perseverance. Curiosity is 8 years into a mission that has shown that billions of years ago, Mars wasn't just wet. It harbored the right kind of environment to sustain life, perhaps something resembling bacteria or algae.
That water was not only there for a long time, but it actually was at a pH level, so it wasn't too acidic and it wasn't too basic. It was actually at the right acidity level to be consistent with the kind of water we know on Earth that is viable for life.
The Perseverance rover is designed to take the search for life up yet another notch, seeking out chemical biosignatures and packaging up samples for an eventual return to Earth. A long way from Sojourner, for sure.
One thing I like to say about the difference between Pathfinder and Perseverance, the Sojourner rover weighed 25 pounds, and just the robotic arm on Perseverance, the weight of the turret and the instruments in the core, it's 80 pounds. So 3 Sojourner rovers on the end of the Perseverance robotic arm, which is quite a bit of progress, I think.
Perseverance weighs about a ton, but sending anything more massive to Mars is a huge challenge. Slowing the craft down in the wispy Martian atmosphere is the issue. Supersonic parachute designs are at their limits, so NASA has tested an inflatable decelerator, a big donut designed to put on the brakes for even larger rovers and maybe one day astronauts as well. For the PBS NewsHour, I'm Miles O'Brien.